Hello there, Year 9. A couple of lessons ago, as the extension activity, I asked you to take a look at this thing that was in the textbook known as the roundabout of British weather, and I said that I'd give you a little bit more information on it because I think it's important that you understand why we have such changeable weather here, and it'll also feed in a little bit to when we do the case study on the beast from the east. Basically, what we can say here is the UK here sits and is affected by five different air masses. Air masses are large bodies of air, and across those large bodies of air they have a uniform temperature, pressure and humidity throughout. They move over large distances and they bring with them the conditions from what's known as their source regions. So I'm going to go through each of the different each of the five different air masses, the types of weather that they bring with them. Okay, we're not going to be seasoned meteorologists after this, but it does give you that understanding of why we have such changeable weather. In fact, a book that I used to use at university started off with the quote that in Britain there is no climate, only weather, because it is so changeable. So the names of the air masses, I've got clues about where they've originated from, where they've come from. So what I'll do is I'll start at 12 o'clock on here with Arctic Maritime. We'll work our way clockwise around, look at the different things, the different weather conditions they bring, and then look at one other factor that can influence the UK weather. So starting off with Arctic Maritime, as you might expect, the source region here is the Arctic Ocean. Its direction of approach is from the north. Now, obviously, because it's coming in from the north, anything to the north of us we can classify most definitely as being cold. So it's going to bring with it cold weather. Because it's a maritime air mass and it's passing over water, because it's passing over ocean, it's going to pick up moisture, and therefore it's going to bring with it some form of precipitation. And I say precipitation rather than rainfall because the type of weather that we'd associate with Arctic Maritime here in the UK is going to be snow and snowfall. We're going to have unseasonably low temperatures, very low minimum temperatures, probably going down to maybe even as far as -10. We're going to have strong northerly winds, which is going to bring again a lot of is going to increase the feeling of cold because the wind's blowing from the north, but it will also bring with it snow. It's very, very rare that we get Arctic Maritime weather, but we know when we've got it, because what will tend to happen is we're going to be getting things like snow, road closures, school closures, etc., because of the fact that we're getting a huge amount of snow and very, very cold weather. Right, moving around to Polar Continental. Polar Continental actually brings with it two different types of weather depending upon the season. If we think about the winter Polar Continental, first of all, the source region, by the way, sorry for here, is Scandinavia and northern Russia. So you're looking at a source region where you have got temperatures that are going to be -20, -25, maybe even colder. So it's going to bring with it, again, because it's coming from the north, it's going to bring with it cold. But because it's coming from the continent and it's not got a huge amount of sea track to cross between Scandinavia and here, there is water, there is sea, there is the North Sea, but it's not really wide. It's not going to pick up a huge amount of moisture. So in the winter weather, it's going to bring very, very cold in the source region. It is warmed. It's warmed also by the sea. We're going to get wintry showers occurring across eastern Britain and around the North Sea coasts. But then we're going to be getting low daytime temperatures everywhere. So anything fluctuating around about zero as a daytime temperature. We'll tend to have clear skies as well, so overnight temperatures are going to drop below freezing. And it's fairly stable. It sticks around for a while. And what we tend to get, you might remember having overnight frosts that go on for 2, 3, 4 nights maybe, something of that region. Now in the summer, it's different. It's very different. It originates over a much warmer source region. So it's cooled as it progresses west. So what we might see then are fogs, coastal fogs and cloud. But when it gets inland, we're going to have clear skies, long hours of sunshine, and temperatures there probably 20s to 25. We might even be bordering there on barbecue weather. So that's the polar continental. Now the things I said coming from the north are cold. The things coming from the east, because they are coming over land largely, are dry. The things coming from the south are going to be warm stroke hot, and that brings us to tropical continental. Its source region is Siberia. Its source region is the Sahara, which is a desert similar to Siberia, but it's a hot desert rather than a cold desert. As a result, as you might expect, it's going to start with a source region where temperatures are going to be hot. It's a dry, hot air mass. Doesn't contain much water. It passes over the Mediterranean, yes, but doesn't pick up a huge amount of water. It passes over the English Channel, of course, but it doesn't pick up a lot of water. And you are going to be looking here at temperatures in excess of 25 degrees Celsius, possibly getting up to 30 degrees Celsius. This is your heat wave weather. This is the kind of weather that we had a couple of summers ago, which was very, very stable, very, very hard for other air masses to dislodge it, and it just stuck around for a long, long time, bringing with it lots and lots of hot, dry weather. Heat wave conditions, like I say, this is when the tabloid newspapers are going crazy with few water scorcher headlines. So that's the tropical continental. Moving around then to tropical maritime. Now I said it's going to be warm or hot because it's coming from the south, but maritime air masses are wet because they come over the ocean. The tropical maritime source region is a small collection of islands called the Azores high pressure cell, which is in the middle of the Atlantic Ocean. So its source region is actually, it's quite warm, but the air cools and it becomes wetter as it moves northeast across the Atlantic Ocean. It brings low clouds, mild conditions to most of the British Isles. There might be some drizzle, and temperatures might be getting up to unseasonably warm winter temperatures, like 10 to 15 degrees Celsius, but it's cloudy, it's wet, it's the warm, wet winter weather. In the summer, we're getting higher temperatures and perhaps more sunnier conditions because the clouds that form over the sea soon evaporate as they move inland. So we're going to get dry, sunny conditions common over most of the British Isles, with maximum temperatures probably reaching around about the mid-20s or so. Now, all four of these are rare in comparison to polar maritime. This is the one that dominates our weather. And the polar maritime comes from the North Atlantic Ocean. It's sort of on the way from kind of Greenland, so we're looking at places where it is very, very cold. And in the winter, obviously, it comes over the sea. It's absorbing water from below, and you're going to be getting below average winter temperatures. And obviously, because it's coming off the sea, we're going to be getting rain showers. They're going to be frequent in the west because that's the point where they're hitting first, and then the air is forced to rise. We get the condensation, the coalescence, and therefore precipitation, which is one of the reasons we think about Oldham, which is probably about here on there. One of the reasons why we have such a damp climate. But temperatures are going to be quite cool. So rain showers most frequent in the west. We might have clear nighttime skies. We might have patches of fog as well. In the summer, they bring in cool northwesterly winds. We're going to have rain showers in the west, and it's just generally that sort of slate grey sky weather that we seem to always kind of get here. So like I said, that one's in the dominance, that's the one that we mostly get, but sometimes we get these very different weather types. Now there's something else that affects the relationship, I suppose, that we have with these air masses, and this is something called the jet stream, which again you might have heard of. I'm not going to go into the complex physics about it. It's dead simple and straightforward what we need to think about here. The jet stream itself is a core or a tube of strong winds. It's about 5 to 7 miles above the Earth's surface, and it's moving in a west to east direction. Its movements, and again this is the complex physics, and as complex as we need to get, the movements within the jet stream, 5 to 7 miles up in the air, affect the surface weather. Okay, and we will talk about the fact that the jet stream can move, and it will move south and it can move north. Now sometimes we might end up, and we have seen this recently, where we've had very unseasonal warm weather, and it's been attributed to the fact that the jet stream has moved north, and therefore the polar maritime, the polar continental that could be affecting us aren't affecting us because they stay generally to the north of the jet stream, and we're under more influence from tropical continental and tropical maritime air coming in. Sometimes, and this is going to be important when we're looking at the Beast from the East case study, which we'll be doing later very shortly, sometimes we might have the jet stream though passing further south of us. It does mean good things for continental Europe because they're going to be getting the tropical continental air, they're going to be getting the tropical maritime air, but we will be drawing in more of the polar maritime and the polar continental. So the movement of the jet stream is important, but it's that's about as far into it as I feel that we need to go. Okay, I am going to set you a couple of tasks to do based upon this, one of which of course is going to be create a much more beautiful and annotated diagram than what I have done here, but that basically is, I think, all that we need to know about air masses and this roundabout of weather that affects the UK. Okay, stay safe y'all, see you later, bye.